Hey guys, it's Simon and welcome back to the LibGDX Kotlin RPG tutorial series. This is the last part where we are going to learn something new about Box2D. After that part, you know almost everything that I know about Box2D and I cannot teach you anything more. What we are going to do, so at the moment we can move around already in our game. We are dynamically creating all these collision objects, so it's actually entities. Then in the end they are also getting removed when we are not close to them. And now in this part we are going to introduce an attack system. In case you're wondering, at the moment our entities are always playing the same animation, so it's either the run or the idle animation, whatever we set, and we never switch the animations at the moment. This will be solved in a later part because what I normally do now in my games is that I link the animation of an entity to its so-called state. That comes then later on when we introduce the AI part, but you can imagine it like this. So an entity can always be in just one single state. So it can be, for example, in an idle state. When it moves, it is in a move state. When it attacks, it's in an attack state. When it dies, it's in a death state, and so on and so forth. And every state is linked to a specific animation that is then played either in a loop version in case of, for example, running or just standing around, or it's just played once, for example, in case of attacking. And if I would introduce this animation swapping now, then we could introduce very strange behaviors. Like, for example, we could move and at the same time attack and maybe even die, and mixing up then those animations. And we would need to introduce several flags to check when can I play what animation and things like that. And it gets very complicated. I will explain that in more detail in that AI part. So that's why we are skipping that for now, just in case you were wondering. But that gets introduced later on. And in this part, we are going to introduce an attack system so that we can, at least from in the background, we do all the calculations to, for example, attack that specific slime and kill it, or attack that specific slime and kill it. All of that we are going to introduce in this part with a new technique in Box2D that we did not learn yet. But also one thing that I noticed, because I'm always watching the entire videos to cut it for you and maybe, take some notes and add some links to the video descriptions and also create the chapters in the video description. And one thing that I noticed, and I cannot tell you why, but our collision entities that we are creating, we are actually in our code checking in a rectangle around an entity if a specific collision object needs to be created, but we are checking in a circle radius if the collision entity can be removed. So there we introduced this circle sensor, and in my opinion that does not really make sense. So I would either change the sensor of the collision objects to also be a box, that it's also a rectangle, or to change our logic that creates the objects to check it in a circle. We won't fix that because I think it's not really relevant that you don't learn something new there. You know all the things that you need to know for that, but just that I mentioned that, and maybe you can fix it in your code. So most likely it's easier to just make those sensors a rectangle as well. Makes more sense and is then more accurate with the creation and the removal, instead of mixing up a rectangle and a circle for those spawning and despawning logics of the collision objects. Okay, so as mentioned, in this part we are going to introduce an attack system, and we want to be able to kill our slime enemies. So what do we need for that? So first of all, our entities need some sort of life, because we need to check if, for example, the life is lower than or exactly 0, then an entity is dead. So this is the first part that we are going to introduce, and for that we create a new component. Let's call it LifeComponent. And that component is quite an easy and straightforward one, I would say. So a life component, what does it contain? It contains the life of an entity, which is a float. For example, by default, our entities have 30 life or hit points. Then they have a maximum amount of life, which is, for example, also 30 as a default value. Then there is a regeneration value, so how many HP does it recover per frame, so for example, or per second, for example, 1 hit point per second. And in addition, because we are introducing an attack system, or damage system, also in this part, the life component will store the information how much damage an entity should take. You could split that up in a separate, for example, damage component or whatever, but to keep it simple for that specific game or example, I kept it in the live component. And we also going to introduce one very simple extension property, which is a check. So if an entity is dead, which is a Boolean, and there we implement the get method, and that one simply returns if the life is smaller or equal to 0. So this is our live component. Then with a new component, we also always need a new system. Let's call that LifeSystem. And there we are going to iterate over all entities which have a live component. And also what we want to do there, we don't have this component yet, but also let's introduce that in a moment. We don't want to iterate over entities which are already dead, because if an entity, so there we are going to introduce a dead component, and if an entity is already dead, so it will be removed very soon, we also handle that in that part, then we don't care about its regeneration or anything else, because it is already dead, so let's include it from that iteration. Okay, so let's quickly also create this dead component. So here in that dead component, for that part, we could simply leave it empty and that's it. But let's also introduce there something that we will introduce then later on, which is a revive time. So what is that? When you remember, maybe you remember it from the first part where I was showcasing the game. There, when the player is actually dying, he is not getting removed, so he's not really dead. He simply falls down on the ground, and after a couple of seconds he stands up again, so he gets like resurrected, let's say, and he's just knocked down, so he's not really dead. And the revive time is what specifies the time until an entity gets revived. So for the slimes we won't use that, but for the player, for example, we can set then the revive time to, for example, 7 seconds or whatever, and then after the time has passed, the entity will get revived. So this is the intention of this revive time. Good, so coming back to our live system, what do we need there? So there, first of all, let's import the dead component, and then we need a couple of things. So we need access to the live components, to the dead components. What else do we need? Yeah, let's start with that. Let's start with the live and dead components. Okay, then of course it is an iterating system again, and we implement the onTickEntity method. So here, first of all, we need the live component of our entity. Then we check, so we apply the regeneration. So from the live component, our live is equal to the live component live plus our regeneration value. And we want to scale that, let's say, with the frame time, because the regeneration will be per second. So we simply multiply it by the delta time. Then, for example, if we have here a value of 1, then within 1 second it will regenerate 1 hit point or 1 life point. And actually, sorry, this needs to be, of course, inside. So we need to apply that to our regeneration, because that is the one that we want to scale. And we also need to make sure that this is not, so that we do not regenerate over the maximum amount of life, so we cap it with the maximum. So this is our life. So every frame we apply this regeneration effect, and entity would regenerate up to the maximum amount of life points that it has. Then the next thing that we do, we check should it take damage, and that one we do after the regeneration in our game here. So if the take damage is greater than 0, then from our live component, the live gets subtracted by the take damage amount. And also we need to reset the take damage to 0, because that one was now applied. Good, and finally, so if after all of that, so after it was taking damage, if an entity is dead, so if it does not have any more life, then we are going to configure that specific entity that we currently get in here, and there we simply add a dead component to it. And here, for example, we can do a special check. So if the entity is a player, so here we don't have that yet, but for example, if it is part of the player components, let's add that in a moment, then we also set this revive time to I think I used 7 seconds in the game, but I cannot remember. But this is, for example, where we check this revive time of the dead component. So let's quickly add also the player components up here. Okay, so that's it, quite straightforward, I would say. So again, first of all, applying the regeneration. After the regeneration, we apply the damage stuff. And after that, so if an entity is dead, then we add the dead component to it with this configure entity method. You can modify the entity during a system iteration. And that's it. And when it gets added, so when this dead component gets added to an entity, then it is not part of the LifeSystem anymore because we exclude it there. Good, then the next one. So now that we have a LifeSystem, we also need a DeadSystem, of course. Here we iterate over all entities which have a dead component. And this is also an iterating system. So what this system needs is, of course, the dead components. Then it also needs access to the live components, because there we need to check, for example, if this revive time is then smaller than 0 and an entity should get revived, then we restore the hit points, so the life points of the entity, back to the maximum so that it's living again. Okay, so first of all, let's get our dead component in here from our entity. And the first thing that we check, so if the dead component revive time is equal to 0, so it is not specified, then we can simply remove the entity immediately. So we remove it and we also return because there's nothing else to do. But if it has a revive time, for example, like our player, then what we are going to do is from the revive time, we subtract the delta time, and afterwards we check now, so if the revive time is smaller than 0, so it's actually the same as above, but here we know it has a revive time, so it can be revived. So here we check now if that is now smaller than 0, then let's revive our entity. And we do it like that, so we simply get the live component of our entity, and there we set the life to the maximum amount of life, and we also need to remove the dead component from the entity. So from the dead components, we remove the entity that we are iterating here over. So that's it. Also, I would say quite simple. So if an entity has a dead component and should not get revived, we simply remove it. And if it should get revived, then we restore its life points and remove the dead component that it is no longer marked as a dead entity. Then we are coming to a more interesting part. So here we are going to create now the last component for this part, which is the attack component. And that one is a little bit more complex. So the way I solved it is that I introduced a so-called attack state. So what is an attack state? You can imagine it like that. So when the player is, for example, standing still and he did not attack for a while, then he would be able to attack. So he's like ready to attack. So this would be the first state that an entity can be in. So we introduce an attack state here, and the first one would be ready. Then when an entity is ready and it wants to attack, then it's going to prepare its attack. So then some internal stuff is set in our logic and it's preparing its attack. So for example, we set the attack animation and some other things. And yeah, then after that, so when it's preparing the attack, then it is executing the attack. So then it's attacking. And at some point, so after a certain delay that is normally dependent on the animation. So for example, the slime has this jump animation, and there maybe only after when the, I don't know, the 4th or 5th frame of the animation is reached, you really want to apply then the damage. So there's then a deal damage state as well. So those are the different states that I have for an attack. And the attack component itself, so there, as mentioned, first of all, an entity can say that it wants to attack. So this is a simple Boolean. So if it wants to attack, then this flag is set to true, but that does not mean that it can attack, because it could be, for example, in the middle of an attack, then of course it cannot attack again. Then maybe we want to introduce other things. So for example, if it's stunned or maybe it gets damage at the moment, then it should not attack anymore. Or there is a certain delay between attacks that you cannot simply spam the attack button, so that there's always, I don't know, maybe a second delay before you can execute the next attack. So things like that are then considered, meaning that an entity, of course, it can say, hey, I want to attack, but maybe our logic prevents it for now. So that's why we also need then these specific states that I mentioned here. So there we have a state, which is an attack state, and initially it's for example ready. Good, then we need to store how much damage can an entity deal. Per default it's, for example, 0. Then there is a delay, so when should the damage be applied? As mentioned, for example, maybe after half a second or something, when the animation reaches a certain frame, so that one we can apply. Then we need a max delay. That one makes then more sense when we implement the system, because one value is the specific configuration for an entity when a damage, so when the deal damage stage is reached and it really deals then the damage. And then of course we need an additional attribute to know what is the current delay. So that's why we have this delay and max delay. That's why we have the two attributes to know the constant of the damage delay and the current delay of an entity. Then what I also introduced is a so-called extra range, because normally our attack system will simply check via the hitbox of an entity. I come to that in a moment. We have it already available. Let me quickly start up the game to explain to you again what is the hitbox, because currently all our entities, they have actually two shapes. So they have a collision shape, which is the one at the bottom here, or for the player it's that one here, and then there is the hitbox. So this would be the bigger rect of an entity. And our system will work like this, that it simply checks, so whatever is inside or colliding with our hitbox of the entity, that one will get damaged. But it could be, like in case of our player, that we have a little bit of an extra range. So it should be a little bit more than this hitbox. And why is that? So for example, when we check out the player animation or the player graphic, so there, let me zoom in a little bit. So as you see here, our player has this little sword. So the hitbox would be still, of course, just the player itself, but the sword, so the swing, is bigger, as you can see here. So this is like, again, there would be another player fitting in, and that would be that extra range. So an extra range of 1 would simply mean like that another world unit of space will be checked for the damage dealing portion. You see that then in a moment in the attack system. But that's the purpose of this extra range. Okay, and then let's also introduce two helper functions, or yeah, in this case properties again. So there will be a isReady, which is a Boolean, and that simply returns that the state is equal to the attack state ready. And we will also have a function which is called start attack. So this is then called when attack should really be performed. And there we change then the states to the prepare state, which means so now the attack is really starting. This one, again, in this part, we will simply call it directly without any checks. So in theory, you could do multiple attacks within a frame and things like that. But later on in the part where we introduce then the state handling of an entity, there it's then handled properly, that the start attack is really only called when an entity is allowed to attack according to our logic. Good, then the final part is now the attack system. So there we iterate over all entities which have an attack component, which have a physics component, because we need to check for the position and also other things of our physics body. And we also need the image component. Why do we need that? Because we need to know if the attack is going to the right or left side. And that one we will check via the flip property of our flip image actor that we introduced in the last part, if I remember correctly. Okay, then there is some standard things that our system needs again, like access to the attack components, physics components, and image components. Then we also need access to our physics world, because there we are introduce something new that you're going to learn in that part. And then again, it's an iterating system. Okay, so let's start. So first of all, we get the attack component of our entity, because that is the core piece of the system. Then we check if the state is ready, so if the entity is ready to attack, and the attack component do attack is set to false, then it means entity does not want to attack and is not executing an attack. So we do nothing and simply return. So that's the easiest part. An entity does not want to attack, so let's do nothing. Then if an entity, let's introduce there also something. So is ready, then we also will introduce a is prepared. And the entity wants to attack. So now it has an attack intention and is ready to attack. So we are going to start the attack. So how does that work? First of all, we clear this toAttack flag, because we reached now the point where it really can attack. So an entity or the player could now make another attack input, but the current one will get processed, so we clear that. Then the state is changing to the attacking state. So from prepare, we are now going to attacking, and the delay is the maximum delay. And that's it for that specific frame. So the delay again, after that delay has passed, we are then dealing the damage. Okay, let's quickly introduce an is prepared as well. So let's copy and paste that here. Is prepared, and there we have the attack state prepare. Good, then when we reach the next frame and we would have processed that, then from our attack component, from the delay, we are going to reduce the delta time. And we check now, so if the delay is smaller than 0 and is attacking, so this is the next check that we are going to do, then we are going to deal damage to nearby enemies, and that will be now the interesting part. So first of all, here let's introduce another simple property. So that one is called is attacking, and that one simply returns that the attack state is attacking. So here we switch now to the final state of our attack state. So that one will be the deal damage state. Then we need to get our image to know in which direction we are going to attack. So we check attack left. That means the image is flipped. And if it is not flipped, then we are going to attack to the right side. Okay, and now I need to explain something. So we want to find out now what kind of entities are within a specific rectangle. So this hitbox plus this additional extra attack range, so it will be simply a rect, and we want to check what kind of entities are inside that rect. And that one we can do in Box2D, so there we can check what kind of bodies are within a specific rect, and that is done via a so-called query. I think I most likely imported here the wrong world, so that one should be the Box2D world. Okay, some import cleanup because I imported the world wrongly. So down here again, so the physics world, the query function. And what do we need to give it? We need to give it the bottom left corner of our rectangle, then the upper right corner of the rectangle, and then we can specify a callback. So for every body which is then detected within that specific rectangle, we can do then a certain action. So this is in contrast to the contact listener that we have in our physics system, where we react immediately to when a contact starts or ends. That one is another way where you can simply query the world at any point in time. So whenever you want to check something, and then to do some action over such bodies that you find there. And since our bodies, Box2D bodies, are always linked to an entity, we actually can then iterate also over those entities that we find that way. And the thing, so this rectangle has a specific name. It is an AABB rectangle or bounding box, which is an axis-aligned bounding box. I forgot actually what that means, but I think it simply means that it is not rotated. So it's aligned to the x and y axis of a normal coordinate system without a rotation. I think that is what axis-aligned bounding box means, but please correct me if I am wrong. And what I found out when I called this function and at the beginning it did not work, and I also did not know and see what kind of things or what kind of area am I checking with that query. So what I did there is that I introduced a companion object. So there I introduced a rectangle and called that AABB rect, which is a rectangle. And that one I simply was rendering in the debug system. We don't do that now, but we do that later. So that rectangle can be rendered with a so-called shape renderer in our debug system, so that we see where is that AABB bounding box and what kind of bodies should we get back from the code. So that makes it easier to visually see what's happening. Okay, but we need to specify now how does that rectangle looks. So we already know, are we attacking to the left or right? Then we need to have our x and y position, which is simply from our physics components, which we did not get yet. So let's get it here. So the physics component is from our entity, the physics component, and there we get from the body not the polygon, we need the position. Then we need something in addition, because the position of the body is not 100% correct, because our body has a specific offset that we set in our spawn system. If you remember, we can also set a specific physics offset to move the body a little bit up or down to be more consistent with our image. And of course, we also need to apply that offset now when we are going to check the hitbox of our attack. And currently we don't store that, but we need to do that. So let's simply fix that. So in our physics component, there we also need to store, let's call it offset, which is also a vector2. And then simply in our entity spawn system, so there, for example, we get our physics component, and there we set the offset to the configuration physics offset. Okay, then coming back to our attack system, here we need to get this offset, which we now get from our physics component. Then we also need the size of our physics body, and there, unfortunately, the body has no size, because for Box2D it makes sense. The body itself cannot have a size like we need it, like a rectangle, because it can consist of many different fixtures which are maybe not even linked together. And what would be then the size? So it would be then, for every little fixture, we would need to check where it is and what is the size there. And to simplify that, I also in that game and also in other games, I simply store the size of this physics body also in a separate property in case I need it. And here we really need it. So again, let's go back to our physics components, and there let's also add now a size, which is also simply a vector2. And again, in our entity spawn system, where we already calculate this width and height of our body. So there we can then also set the size, which is the width and height. And then back in our attack system, we can get that. So there we have the size X and size Y, which is the size from our physical component body. Let's call that simply width and height to keep it a little bit shorter. And as always, you know that we need this half of the width and half of the height, because in Box2D everything is centered, and we need to get now to the bottom left corner of our bounding box and to the top right corner. So let's also store that here. So the half width is simply the width multiplied by 0.5, and we also need half of our height. Good, and now we can do something. So if we are going to attack left, then our AABB rect looks like this. So we have the X position, then we need the offset on the X coordinate, then we need to reduce half of the width, and we also need to reduce the extra range from our attack component. Then the Y, so the bottom left corner, is simply the Y position plus the offset of Y minus half the height. Then the top right corner of this rect is again X plus offset X plus half the width. And the Y coordinate, the top right Y coordinate, is Y plus offset Y plus half of the height. Okay, and if we are not attacking left, then we are attacking right, obviously. And there it's now different. So there we need to apply the extra range on the top right corner. So there we need to add the extra range to the top right corner. Everything else remains the same. And now we can query our world, so the physics world, and there, okay, we really need to specify the X, the lower X and lower Y, and upper X and upper Y. So this is from our AAB rect. This is the X coordinate, then this is the Y coordinate, then this is the width, and this is the height. And there we get in a fixture, and now we want to execute some code over that. And let's quickly check that. So this query method has a KTX query callback, and that one is a fixture, and we need to return a Boolean. And the lambda returns whether to terminate the query. So true means stop it, and false means continue, I guess. Or maybe the other way around. Sorry, let me quickly look that up. Okay, so according to the documentation, if I understand that correctly, so returning true means that we continue with the query and iterate over the other fixtures. And if we would return false, which we don't want in that case, because we want to find out all the entities which should get damage, but maybe you have some other query, and there you're maybe only interested in the first entity that you find, there you can then stop the execution of the other fixtures by returning here false instead of true. But in our case, we always want to return true because we want to keep going. So the first thing that we do, we want to check, is our fixture, is it a hitbox? So there is a user data, and there we want to check, is the user data not a hitbox sensor? We did not introduce that yet, but we do that in a moment. Then we want to return, because we are only interested if we really if we detect hitboxes in that specific case. And what is a hitbox? So we actually created that already. So this is our hitbox here, but that one does not have a user data yet. So for us, we could also check if it is a sensor or not, because we only have either a sensor or not, from what I remember. But I think it's cleaner to really give that a specific name, and that one we call here hitbox sensor, which is simply a string. So let's also specify that at the bottom of our spawn system, and make it also a constant. So that one we can now use in our attack system here. And let's also return here true. and also here true, to get rid of these red arrows that are popping up because we are not returning anything. Okay, so we are iterating over all these fixtures that we find with our query. If it is not a hitbox sensor, then we are not interested and then just go to the next fixture. Otherwise, we know it is already a hitbox sensor. So now we want to get the entity for it. And there, as you see, so this is really a normal fixture, and we already have in our physics system, if I remember correctly, there we have some extension function which gives us back an entity, and now we need that again. So that's rather a quick and dirt fix, I would say. So I simply put that now on the top and do not make it private anymore, so that we have access now to this function from anywhere. But the cleaner solution most likely would be to have a separate box2d file with all the extensions that you're going to create for box2d related stuff. But for us, we want to keep it simple. So here we simply want to have the fixture entity, which is from the fixture, the entity. Okay, and if the entity that we find here is the entity of our current iteration of the attack system, then we also want to continue, because we don't want to attack ourselves. So what do I mean by that? So obviously this query also returns the entity itself, which is attacking, and we don't want to do that. So of course an entity attack should not damage itself. It should only damage other entities. Okay, so finally when we are here, so now we know this fixture entity is actually another entity which is not currently attacking, and that one we want to damage now. So we learned already there is this configure entity function, and there to our fixture entity we want to check, so does it have a live component? Didn't we add that yet? We don't have that yet. Okay, so let's also bring in here live components. Okay. So if the entity, we can use here it actually. So if the entity has a live component, let's make here the get or null call to be safe again. So if it has that, then we set the take damage amount to the attack damage that our entity is actually dealing. So this is plus equal to attack component damage. And to make it a little bit more exciting, instead of always dealing a fixed amount of damage, we make it here a little bit random. So mathutils random. And there, let's say, for example, either 90% and up to 120 or 110%. So that is the fluctuation here, that we have a little bit of a random factor. And we want to put that here on top, because in theory it could be that you take multiple damage from different sources within one frame. So that's why we make here a plus equal to add then already on the damage that the entity gets, to add it here then on top of it as well. Okay, and that's actually then it. So here we applied the damage, and the last thing that we need to do now is that we change our attack state back to ready, which I think might be confusing to you. Yeah, so here we are setting it to deal damage, and then actually within the same frame we set it back here to ready. But please note, so that part here gets optimized or modified then in the future, because what we want to do actually, we want to check, is the attack animation finished? And only when the animation is done, we go back to the ready state. So after the animation is finished, only then the entity can attack again. But since we don't have that yet, so we don't have included this attack damage animation, and we introduced that only later on. So that's why for now we immediately change here to the ready state again, and we would be allowed to attack again and again. Then there's also a small It's not really a bug, but there's a, let's say, a side effect in that code. Can you spot it? So it's in here in this query code here in the callback function. What could that be? So the problem is we are checking that we are not dealing damage to ourselves, but we are not checking if we are maybe allied entities. So for example, with this piece of code, it actually can happen that when a slime is attacking, he's then also dealing damage to another slime, which should not happen because they are enemies and they belong together, so they fight the player together and should not attack themselves. But with that current code, that is happening. And it's also the same thing in the GitHub code. And to solve that, you would need to somehow mark what kind of entities belong together. A simple solution would be, so you could check, so if it is the player, so if the entity is a player, then he only deals damage to entities which do not have a player component, and if the entity does not have a player component, then it also only deals damage to entities which have a player component. We don't implement that now. I think that's not important, but just that you know it, that would be one solution. But you can of course make it more complex. Maybe you have, like in Warcraft 3, you have different allies, so you could be allied to certain other entities or races in your game, and yeah, make a more smart logic what kind of things can attack each other and what kind of things would be friendly fire or which cannot be attacked by each other. So that one I leave up to you. We leave it with that piece of code. Good, so we have our LifeSystem, we have our DebugSystem, we have our AttackSystem. What we cannot do at the moment is attacking because our player is stupid and does not know that, so we need to change the code in our player input processor. And they are simply in the key down method. So there, if it is not a movement key, we check is the key code space. That will be our attack key. Then we iterate over all our player entities, and for the attack components of that player, we set the do attack to true. And to do that, we need the attack components, of course, in that input system. So let's do that. And it's not an input system, sorry, it's an input processor. So there we know all our, or we simply assume that all our player entities have an attack component, and when you press the space button, then we say, hey, we want to attack, and set this flag to true. Okay, so now we need to add the systems to our game screen so that they also do something. So for example, let's make the attack system after the move system. Then let's also add here the live system, and we also need to add the DeadSystem. And here we need to be a little bit careful because actually what we're going to implement that later on. So in the live system, when an entity is dying, then its death animation is played. And in the DeadSystem, we then check if the animation is finished. So if the death animation is done, only then we are going to remove the entity. But you can imagine, so in the live system, we set this animation, but the real animation setting is then only happening later on. So here in that animation system here below, which resets it, so the check in here would not be correct in that specific frame. So that's why it's important to move the DeadSystem before the live system, so that our logic is then executed in the correct order. So we set here, for example, the death animation. Here in that system, that will get updated and the state time is set to 0 and so on. And then in the next frame, when we check the DeadSystem, then the death animation is correctly set and the logic works properly. So there, it's I think the first time maybe where we need to be a little bit careful with the ordering of our systems, that we don't have any strange side effects. Okay, and I see also here in the input mapper here below what we can do to, so that we don't need to adapt this code here all the time. We can simply initialize that here in the constructor of our input processor by simply using or applying the mapper here. That makes it easier than the code here below is working. Good, and the last piece that is now missing is the debugging of this axis-aligned bounding rectangle, and as mentioned, we are going to do that in the debug system. So there, let's create a so-called shape renderer, which is responsible to render shapes. Who would have thought that? Okay, so when our debug system is enabled, then we are going to create a new shape renderer, and then here simply we use our shape renderer, and there we can specify certain things. So first of all, how should the shapes be rendered? So should they be filled, or should there be a line, or should there be a point? I don't even know what that means. So what we use here is a line. So we don't want to have filled shapes, we want to have lines, which is actually the same thing that the physics renderer of Box2D is using. So we will see then different lines. And we want to have, again, from our stage, from our camera, the combined matrix. And then we simply, from our shape renderer, we set the color. So let's make that, for example, red. And we want to draw now our axis-aligned bounding box. So AABB rect. Did we call it like that? Yes. So there our x coordinate, then the y coordinates, then the width, let me think about that, and then the height. I think that is not correct, because in our case, the width and the height is actually the top right corner position of the rectangle, and not really the width and the height relative to this initial position. So I think we need to subtract here the x value and here the y value, if I am not mistaken, but let's see. And the last thing is here below a shape renderer. You might have guessed it as well. That one also needs to be disposed. Okay, so that was so many systems and things that we now added. Let's see if I broke something. So at least it's starting up, so that is a good sign. Then let's go here a little bit below. And now I press the space button. And something is crashing. Okay, what is crashing? Ah, of course. What did we forget? Yeah. Who was saying it? I heard someone saying it. Of course, we did not add all our components yet to our entity. So they don't have an attack component, they don't have a live component, and they don't have a that component they get anyway later on. But they don't have a live and attack component. So we need to fix that, of course. And as always, we need to adjust our spawn configuration and the entity spawn system. So let's move that up here a little bit. So first of all, we have a value if an entity can attack, and by default that is true. But for our chest, for example, we can say that it cannot attack. And then we have, as always, an attack scaling, which is normally 1. And of course, we need there then some default attack damage. So default attack damage equals to 5, for example. Then in addition, what we need is the attack delay, which as a default value for that game, I took .2 as a value. And we can also specify an extra attack range for our component, for our attack component, which is 0. I think that's it for the attack part. And then we also need life scaling. And there we also have a default life, which is, for example, 15. And it can be actually an integer. Okay, I think that's it. So let's go to our entity spawn system. And to our configuration. So first of all, the chest can attack is false, because our chest cannot attack. Then for our player, so what kind of values did I pick? So for the attack, how is it called? Attack extra range. How did we call it? I already forgot it. Attack extra range. That one is 1.5 for the player. Ah, sorry, no, it's, I cannot even read the values that I chose there. So it's 0.6, and then we also have an attack scaling, which is 1.25. And let me also close this console here that we are not getting distracted too much. Good, then our chest also has no life, so we can set here the life scaling to 0 as well, because it cannot attack and it also does not need a life. And for our slime, there we have a life scaling of 0.75, and I think that's it for now. Okay. So coming up here, what we need. I see here we have a speed scaling. Okay, we set that to the chest to 0, so that is correct. So it also does not get a move component. Then the next thing that we check, so if an entity can attack, then it gets an attack component. And there we have this maximum delay between attacks is the attack delay of the configuration. Then the damage is equal to the default attack damage multiplied by the scaling. So the attack scaling. And we actually round it to an integer and not just cut it off. Then we also have an extra range, which is from our configuration, the extra range. And then we also need to check for the life scaling. So if that one is greater than 0, then an entity also gets a life component, where the maximum amount of life is the default life multiplied with the life scaling. And we also initialize the life with the maximum life that the entity has. Okay, I think that should be now it. So now our entities have an attack and a life component, and now we should not crash anymore. So before I move, okay, there was one final mistake in it because we don't have the state handling yet and the animation handling, as I mentioned. So in our player input processor, so before, let me return the code, we just set the attack flag. And I simply analyzed that and quickly found out that this is a problem, because with that, we have this flag set to true, but we never enter the prepared state, so we are never entering that branch, and also we're never entering the damage part of our code. So that's why we need to adjust that, and for now we simply do that in the controller, but again later on we fixed it correctly so that you cannot just always start the attacking immediately, so there's some condition. But we set that so to also set this state to the preparation. And now when we check the code, so now everything is working. So as you see, now we have this red rectangle, and that is the attack area that is checked for attacking. So this is when we look to the right, and for example this is it when we look to the left. So you see it's perfectly aligned with our hitbox, and it has this additional extra range because the player is then swinging a sword later on, and this is exactly that range here. And now it's a little bit unspectacular, but that is already working. So when we attack a slime, it now got damage. We don't see that, but we add that in the next part, that there's a number popping up that you see that you are dealing damage as a player. And when we attack it multiple times, at some point he's then dead and simply gets removed. So I think it's 2 attacks if I press quickly. Yeah. So if I wait a little bit, he's regenerating, but if I attack quickly, it's 2 times. And yeah, so that's actually it. And At the moment, it's a little bit unsatisfying because the slime simply gets removed without the def animation, and also we don't see any numbers for the damage that we deal. But that one, at least the number part, so that we have some visual feedback of the damage dealing, we are going to fix that in the next part. Okay, so that was again a bigger part where we added a lot of things. I think at the beginning it was hopefully not that complicated with the live component system and dev component and system, and then a little bit more of a complex part again with the attack component and system. And there the important part for you to remember is this query method of the Box2D world, which is the final thing that I can teach you about Box2D. Then you really know now everything. So you know how to create bodies, how to create fixtures, you know the difference between a sensor fixture and a non-sensor fixture. You have seen the contact listener. You know how to move something with the impulse. There would also be forces for, I don't know, a wind or whatever. And we now have also this query method to get bodies out of a specific area of the physics world. Okay, I hope you enjoyed it. Please let me know in the comments, and I wish you a nice day. Have a nice evening, day, or whatever you have when you are watching this video. Bye bye.